Okay, so this is the polynomial and synthetic division homework. So the big difference between long polynomial division takes more space, for one thing. Also, when you divide one polynomial by another, the polynomial you're dividing by has to be just a simple linear term like this, x plus or minus something. If you have something like x squared, you've got to use long division. So we could do these using synthetic division. This one we have to use polynomial division. And the whole idea here, what's the purpose of doing this? Well, if we want to find out whether this is a factor of this polynomial, we need to divide it out. If we have a zero remainder, then this is a factor of that polynomial. Also, when we talk about slant asymptotes, we need to be able to do this as well. We'll also find out that the remainder after doing division is the value of the function associated with this factor. So at x equals 4, if I evaluate this function at x equals 4, I'll get the same value as the remainder from this division, and we'll see that later. Okay, so polynomial division or long division is just like division with integers, except it's a lot harder, right? Okay, so we write thing we're dividing by, we put here. Thing we're dividing into, we put there. And then we need to pick some value, either x squared, x, or constant, the appropriate value to try to eliminate each one of these terms in succession. Now, if we don't have one of the terms, like we have x cubed and then x, we have to put a zero x. We have to put the zero terms in there. We can't just leave them out, and we'll see that later as well. Like this one here, we have x to the 4th and x squared, so we're going to have to put in 0x cubed and 0x. But for this one, we don't have to worry about it because we got every term. So the whole idea is you look at the biggest term that you have remaining, the one that's the highest exponent, and so what we have remaining is the original polynomial. And you ask the question, what do I need to multiply x by to get 5x squared? So it's always multiplying this to get something here. So if I multiply x by 5x, I'll get 5x squared. So we put that up there, 5x, and we always put it over the value, the appropriate vertical position. So here's the x vertical position. Here's the x squared. Here's the constant. So we just line those up. Now once we've chosen that, we multiply both of these terms by this things that we've chosen, because we're just trying to eliminate this right now. So that's how we make the decision. So we take 5x times x, so that's 5x squared, and those are the same. 5x times negative 4, so that'd be negative 20x. But what we do with the division like this is we actually subtract what we have. So let's liken this to regular division. So if you have 24 divided by 5. So you ask, what can I multiply 5 by to get 2? Well, there's no answer, so we're going to go to the ones case. What do I need to multiply 5 by to get 24? Well, if I multiply 5 times 4, I'll get 20. If I multiply by 5, I'll get 25. So you pick the number that's less. 5 times 4 is 20. Write that down. Then we subtract. So notice I wrote 20 down. 5 times 4 is 20, but then I subtract, and that leaves 4 left over. So if I were to show this with numbers, I'd say, 24 divided by 5 is equal to 4 with the remainder of 4. Now if I had 25, what would happen is I could say, what number times 5 gives me 25? Well, it turns out I can get the exact number, so you get 5 times 5, which is 25. But you're really subtracting it. then you subtract and you get 0. So what I'd say is 25 divided by 5 is equal to 5. And I could put in a remainder of 0, but if I don't put that, then I know that it's implied that the remainder is 0, and that goes in equally. So the same kind of thing applies here. Let me get rid of that. So when I do this multiplication, I get that, but then I subtract it. So I always put it in parentheses, put a negative sign out front, and then draw a horizontal line. Then I add these two lines together with the negative. So I add 5x plus negative 5x. That'll give you 5x squared plus a negative 5x squared gives you 0x squared. Here I have negative 17x. I'm adding 20. Negative times a negative is positive. So 20 minus 17 is going to be plus 3x. Okay, so that's like having something left over, but I keep going until I get all the way to the constant part. So I do the same thought process here. This is my highest order term. I've eliminated this one. So that the question is, what do I need to multiply x by to get 3x? Well, the answer is plus 3. I put it in the column for the constants. And then I multiply out. So 3 times x. Well, before we do that, though, let's bring down what we have left over. So put minus 12. We just bring that number down. Okay, now we'll multiply out. 3 times x is 3x, and 3 times negative 4 is negative 12, but I'm subtracting it. So 3x plus a negative 3x is 0x, and negative 12 plus 12 is 0. So the answer in this case over here is going to be 5x plus 3, and there's a remainder of 0 because I don't have anything left over. So this one, what we would know is that x minus 4 is a factor of this expression. And what we have left up here, 5x plus 3, is the other factor. So because we have a 0 remainder, we know that x minus 4 times 5x plus 3 should equal 5x squared minus 17x minus 12. So let's just check that out. So x times 5x is 5x squared. X times 3 is 3x. Negative 4 times 5x is negative 20x. And negative 4 times positive 3 is negative 12. And you combine the two like terms in the middle, you get negative 17x minus 12. So check. So that's the kind of thing we're looking for. Hopefully, that we're going to pick the right factor to make this go to with 0 remainder. But you know, that's the goal, but it's not something we have to have happen. Okay, so the next one, we're going to take x cubed plus 4x squared minus 3x minus 12. We're going to divide that by x minus 3. Okay, so what do we need to multiply x by to get x cubed? Well, the answer is x squared. So we put that up there. Again, we're just looking at this term and this term. And what do we need to multiply this term to get that term? The answer is always this divided by that. You know, x cubed divided by x is x squared. Okay, so let's multiply it out. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Put a line. I'm subtracting that. I'm not going to write down 0. I'm just going to say it disappears. X cubed minus x cubed. Here we have 4x squared plus 3, because you've got a negative times a negative. So this is really 4 plus 3, which is going to be 7x squared. Bring down the next term, like that. Okay, what do we need to multiply x by to get 7x squared? The answer is 7x. Multiply this now by those two things. So we have 7x times x, which is 7x squared. We have 7x times negative 3, which is negative 21x. But we're subtracting that so that we can eliminate this term. So that goes to 0. Here we have negative 3 plus 21. So that's going to be 18x. Let's bring down the next thing, minus 12. Okay, final try here. What do I need to multiply by x by to get 18x? The answer is 18. Okay, multiply that by both of those terms. 18 times x is 18x. 18 times negative 3 is going to be, that's 30 plus 24, 54. So it's going to be negative 54. But I'm really subtracting that. So those go to 0. And what I'm left with is negative 12 plus 54, which is going to be 42. So the answer for this one is going to be x squared plus 7x plus 18 with the remainder of 42. Another way of writing that would be x squared plus 7x plus 18 plus 42 divided by the original thing we're dividing by. So that's another way of doing. It's not really it is the remainder, but this is the actual thing. Now, one of the interesting thing is that f of 3, the value of this original function at x equals 3, where this thing goes to 0, should equal 42. So let's try that out. Let's see if it works. So if we take 3 cubed, so I'm plugging 3 into there, plus 4 times 3 squared minus 3 times 3 minus 12. So we get 3 cubed is 27, 3 squared is 9, times 4 is 36, minus 3 times 3, which is 9, minus 12. And if you plug those into your calculator, if I can find my calculator, there it is. So 27 plus 36 minus 9 minus 12 equals 42. It did work. Okay. So even if we don't get a 0 remainder, that remainder is useful. It's going to be useful because it's going to be the value of the function at whatever causes this denominator to go to the thing we're dividing by go to 0. Okay. Now the last one, it's going to be a little bit more interesting. So we have this, which we're dividing by, or dividing into. So you have x to the 4th, but we don't have an x cubed term, so we put in 0x cubed. We do have an x squared term. We don't have an x term, so we put 0x, and we have a constant term. So you got to make it longer. And then we have x squared minus 2x plus 3. Okay, so you start off the same way. What do I need to multiply x squared by to get x to the 4th? Well, the answer is x squared. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. And x squared times 3x is plus 3x squared. I'm really subtracting that. So I've got this minus that, which is 0. I've got 0 I'm not subtracting 2, I'm adding 2. So I'm going to get 2x cubed. And this minus 3x squared is going to be 0. So I get 0x squared. Now I'm not going to bring anything down yet because I've still got the, well, I guess I could. 0x. Okay, next thing. What do I need to multiply x squared to get 2x cubed? The answer is 2x. 2x times x squared is 2x cubed. So I multiply this times each term. So I'm going to get 2x cubed. 2x times negative 2x is negative 4x squared. 2x times 3 is plus 6x. I'm really subtracting that. So I add these two together, get 0. Add these two together. 0 plus 4 is 4x squared. 0 minus 6x is negative 6x. Let's bring the 1 down. Plus 1. And then our final step is, what do I need to multiply x squared by to get 4x squared? Well, the answer is 4. Multiply each term by 4. 4 times x squared is 4x squared. 4 times negative 2x is negative 8x. And 4 times 3 is 12. So we subtract that each term. This goes to 0. Negative 6 plus 8. Negative and negative plus 8. So that's going to be 2x. And 1 minus 12 will be negative 11. So we don't actually have, because we're dividing x to the 4th by x squared, we don't have a single number. So you're not going to end up with, well, that's not true. We did get one here. That's just because we just had a single number left, but in this case we don't have a single number left. So what we can say here is it's going to be x squared plus 2x plus 4 with a remainder of 2x minus 11. Another way of writing it is x squared plus 2x plus 4 plus 2x minus 11 divided by the original denominator, like that. So that's what we get. Yeah, how do you check something like this? Well, one way you could plot this original function, and you could plot this function, and if they come out on a graphing program to come out to be the same thing, then you know you've done the right thing. Let's actually do that because I don't know what the answer is, so I'm going to use this to help me out, just to check things out. Okay, so what I'm doing is I'm plotting the original function, which is going to be x to the 4th plus 3x squared plus 1. And I'm going to, so let's graph that. So that's what it looks like. And then I'm going to plot this result, which is x squared plus 2x plus 4 plus the quantity 2x minus 11 divided by x squared minus 2x plus 3. And hopefully I see the same. Uh-oh, got a problem. So they're not the same thing. So what did I do wrong? Let's make sure I entered this right first before I start going back. Yeah, that looks right. And the other one looks... Oh, no. I still got the original function I have to divide. Let me move this out of the way. What I'm trying to do is I'm trying to plot that thing. So I still need to divide the original function, the original numerator, by the original denominator. So what I've got is this divided by that. Now if I graph them both the same, you can see there's just one function. So it's the same thing. That was good. Didn't want to have to go look for that error. Okay, so that's long division. Now synthetic division, you'll notice that all of the things we're dividing by are x plus or minus something. In this case they're all plus, but they could be minus. So the way synthetic division works, if you remember, is you make this kind of bracket looking thing. You put the coefficients of the thing that you're dividing. So I've got 5x cubed, so I'll put 5. I've got 18x squared, so I'll put the next one's 7, the final one's 6. Now the number you use is not plus 3, it's the number you would get if you set that equal to 0. So you'll get negative 3. So we're going to use negative 3 here. Okay, so you take this number, bring it straight down. Negative 3 times 5 is negative 15. Add these in the column again, so you'll get 3. Negative 3 times 3 is negative 9. You add these two together, you get negative 2. Negative 3 times negative 2 is plus 6. You add these two together, 0. So what this is saying is that the answer is going to be equal to 5x squared plus 3x minus 2 with a remainder of 0. So if you get a 0 here, it means the remainder is 0. These coefficients go in order, so this is going to be the highest order. If you divide a third order polynomial by a first order polynomial, you'll end up with a second order polynomial. So this is going to be 5x squared plus 3x minus 2 with a remainder of 0. Or, well, that's the only way you could, I mean, you don't have, in this case, if you have a remainder of 0, you don't have to actually show it. You can just write it kind of like that. So another thing that you can say is that the original numerator here is going to be equal to the factor that we had here, x plus 3, times what I have left over, which is 5x squared plus 3x minus 2. And now, if I wanted to see if there was a factor associated with this, I could use completing the square, quadratic formula. I could do it by observation. So a lot of times we're trying to figure out what this one of the factors is, so that we can get from a third order polynomial to a second order polynomial, and then just use other techniques to come up with all three factors, if there are three factors, three real factors. Okay, next one. Notice there's no x squared, so we have to put a 0 in there. So the coefficient in front of x cubed is negative 1. Coefficient in front of x squared is 0. There's no x squared. Put a 75 for x and negative 250. We don't use x, we don't use 10. We set x plus 10 equal to 0. So what we're using here is the not the factor, but the value where the function would go to, where this would go to 0. Okay, so bring this down. Negative 10 times negative 1 is positive 10. 0 plus 10 is 10. Negative 10 times 10 is negative 100. 75 minus 100 is negative 25. Negative 10 times negative 25 is positive 250. You add these two together, you get 0. So that means for number 5, this divided by that is going to be negative x squared plus 10x minus 25 with a remainder of 0 again. Or we could say that the original numerator is going to be equal to this factor, x plus 10, times what I've got here. Like that. And again, if I could factor this, whatever quadratic factor approach I want to use, you can kind of see what it's going to be if I factor out a negative sign. Let's just, they don't ask for this, but if you factored out a negative sign out of that, you'd have x squared minus 10x plus 25. And then this would be x minus 5 quantity squared. So that would be this original thing factored. So it has zeros at negative 10 and positive 5. It has a multiplicity of roots at 5. Okay, and the last one. Okay, so we're going to do the problem number 6. And I recorded the solution. I forgot to push the record button, so I'm just going to go through it, but I'm not going to rewrite everything down. So let's work through this thing. So we take the coefficients of this numerator, x to the 5th minus 13x to the 4th, and we'll notice that it doesn't have any x cubed terms, it doesn't have any x squared terms. So we put zeros where those would go. So we have 1, negative 13, 0, 0. We have negative 120x, negative 120, 80. Okay. So we bring down the 1. Negative 3 times 1 is negative 3. Negative 13 plus negative 3 is negative 16. Negative 3 times negative 16 is 48. 0 plus 48 is 48. Negative 3 times 48 is negative 144. 0 plus negative 144 is negative 144. Negative 3 times negative 144 is positive 432. Add these two together, you get 312. Negative 3 times 312 is negative 936. And 80 plus negative 936 is negative 856. So what we're looking for is, what is the result? And we have a remainder. So what we end up with, we'll come back to that. Let's that's down here further. But one thing is the remainder is the value of the function evaluated at this value of x, which is x equals negative 3. So it should be equal to negative 856. So if we plug that into the original numerator, x to the 5th, so we have negative 3 to the 5th power minus 13, negative 3 to the 4th power minus 120, negative 3 plus 80. And if you carry that out, so let's see if we've got those numbers. So negative 3 to the 5th power, which is negative 3 times negative 3 times negative 3 times negative 3 times negative 3, is negative 243. Negative 3 to the 4th power is positive 81. Positive 81 times negative 13 is this. Negative 3 times negative 120 is positive 360. There's the 80, add those together, you get negative 856. So it is true. The actual answer here, what is this divided by that? You take the coefficients that you have left over after you do the division, and you count how many you have. 1, 2, 3, 4, 5. This is the remainder. So you have x to the 4th, x cubed, x squared, x constant. So we have 1x to the 4th minus 16x cubed plus 48x squared minus 144x plus 312. And the remainder is this constant, negative 856, divided by the original denominator. Okay, so that's how that one works. Okay, next group of problems. Express the function in the form, meaning the function shown, in the form of x minus k times q of x plus r, and demonstrate that f of k equals r. So we're going to do this one first. So I need to find that, which must be this one here, maybe. Yeah. So what we're going to do is we are going to do this division by x minus k. So k is -2, so x minus k. X minus a -2 is +2. So that's what we're dividing by. That's what this factor is here. X minus k is going to be x plus 2. This part is going to be what we have left over. And the remainder is this number. Okay, so let me put my little screen here. So take the coefficients in front of each one of these terms. 1, -5, -11, 8. Write them down. The number we use here is not +2, but it's the k part, which is -2. It's the value of x that makes this go to 0. So synthetic division is you bring down the 1, -1 times -2 times 1 is -2. Add these together, get -7. -2 times -7 is +14. Add these two together, you get 3. -2 times 3 is -6. 8 plus -6 is 2. So the answer here is you take x plus 2, x minus k, times the polynomial associated with these coefficients, x squared minus 7x plus 3. So what we can do is we can rewrite the original function as x minus k times x squared minus 7x plus 3 plus the remainder. Also, f of -2 should equal the remainder. And one reason why is because if I put -2 in here into this function, x equals -2, I'm going to have -2 plus 2 is 0. So this goes to 0, so that all that's left over is that remainder. So is that what I have next here? So yeah, if I plug in f of -2, according to this, the remainder is 2, so the value of functions should be 2. So if I take -2 and plug it into the function, you'll see I get -2 cubed minus 5 times -2 squared minus 11 times -2 plus 8. And -2 cubed is -8. -2 squared is 4. 4 times -5 is -20. -2 times -11 is positive 22. Bringing it down, you get the answer 2. So it doesn't work out. Okay, so let's move this one up to there. So the next example has a square root in there, so it just makes it more interesting. So k is the square root of 2. This factor is going to be x minus the square root of 2. So we're going to divide this polynomial by x minus the square root of 2. So we use square root of 2 there. So here's what we do. So we don't have these yet. We're going to get this in a second. Bring the 1 down. 1 times the square root of 2 is the square root of 2. 3 plus the square root of 2 is 3 plus the square root of 2. The square root of 2 times this, well, square root of 2 times 3 is 3 times the square root of 2, and the square root of 2 times the square root of 2 is 2. When you add these two together, we add the two ones that don't involve the radical, so you have -2 plus 2, so those cancel out, and you're left with 3 times the square root of 2. Then you multiply the square root of 2 times 3 times the square root of 2. Well, the square root of 2 times the square root of 2 is 2, so 3 times 2 is 6. And then we add -14 plus 6 gives you -8. So putting in this form, so taking the original polynomial here and putting into the form requested, you're going to have x minus k, so it's going to be x minus the square root of 2 times q of x, which is this thing right here, which is going to be x squared plus
3 plus the square root of 2 times x plus 3 times the square root of 2. So that's that part, x minus k times the second part, and then you're going to add the remainder, which is negative 8. And f of negative 2, or f of square root of 2, should be equal to negative 8. Again, because what happens is if I put the square root of 2 in here, this term goes to 0, so this whole thing drops out here, and all you're left with is negative 8. So let's do that. So we're going to use this f of x in problem 8. We're going to plug in the square root of 2. So you have the square root of 2 cubed plus 3 times the square root of 2 squared minus 2 times the square root of 2 minus 14. So the square root of 2 cubed is going to be the square root of 2 times the square root of 2 times the square root of 2. But the first two square roots multiplied together give you the number inside the square root. So this becomes 2. So square root of 2 cubed is the same as 2 times the square root of 2. Here, the square root of 2, the second term, square root of 2 squared is just 2. So you get 3 times 2. Third term is just 2 times the square root of 2, so we'll bring that down, bring negative 14 down. And you can see the first term and the third term are the same, except one's positive and one's negative. So they cancel out, so we just take 6 minus 14, which is negative 8. And that's what we expected. Where is this useful? Well, again, by using synthetic division, the remainder is the value of the function evaluated at x equals whatever this number is that we start. Okay, so those are them. The next group is we just have to verify what we just talked about. So we're going to evaluate we're going to use synthetic division to figure out what the remainder is. If we use 2, we divide this by, not by 2, but by x minus 2. And what the remainder will be the value of the function. This function evaluated to the same for all these other ones. So I think, yeah, they're here, they're all here, so we'll go through each one separately. So the first one, g of 2, so we're going to use synthetic division. The coefficients of the original expression are 1 times x to the 6th, so that's 1. There are no x to the 5th, so we put 0. There's negative 4x to the 4th, so there's 0 x cubes. There are 3 x squareds. There are 0 x's, and there are 2 at the end. So we bring 1 down. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. 3 plus 0 is 3. 2 times 3 is 6. 0 plus 6 is 6. 2 times 6 is 12. 2 plus 12 is 14. Therefore, the function x to the 6th minus 4x squared should equal 14. So we're going to plug in 2, the value. 2 to the 6th minus 4, 2 to the 4th, plus 3, 2 squared, plus 2. 2 to the 6th is 64. 2 to the 4th is 16. 2 squared is 4. Put those in there. 64 minus 4 times 16. Well, 4 times 16 is negative 64. So, or 64. So those the first two terms cancel out. You got 3 times 4, which is going to be 12. 12 plus 2 is 14, which is the same number we got here as the remainder. Okay, next one, f of, or g of negative 4. So everything is the same, except we put a negative 4 here. The top row is exactly the same. You can bring the 1 down. Negative 4 times 1 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 4 16. Negative 4 plus 16 is positive 12. Negative 4 times positive 12 is negative 48. 0 plus negative 48 is negative 48. 4 times negative 48 is 100. Negative 4 times negative 48 is positive 192. 3 plus 192 is 195. Negative 4 times 195 is negative 780. 0 plus negative 780 is negative 780. Negative 4 times negative 780 is 3,120. Add 2, you get 3,122. So this function evaluated at negative 4 should equal 3,122. So plug in negative 4 into the equation. See each term results in that. And if you add this together, you get 3,122. Okay, next one is 3. So again, this is changes to 3. And then you have our coefficients of the original function. And we do the math. So bring the 1 down. 3 times 1 is 3. 0 plus 3 is 3. 2 times 3 is 9. 9 plus negative 4 is 5. 3 times 5 is 15. 0 plus 15 is 15. 3 times 15 is 45. 3 plus 45 is 48. 3 times 48 is 144. 0 plus 144 is 144. 3 times 144 is 432. 2 plus 432 is 434. So if we evaluate the function again at positive 3, we'll get that. And if you do that, you get these numbers. 3 to the 6 power is 729, so forth and so on. You get 434. And then the final one is negative 1. So put negative 1 here. Bring the 1 down. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Click that thing. So there we go. Negative 1 times negative 1 is positive 1. Negative 4 plus 1 is negative 3. Negative 1 times negative 3 is 3. 0 plus 3 is 3. Negative 1 times 3 is negative 3. 3 plus negative 3 is 0. Negative 1 times 0 is 0. 0 plus 0 is 0. Negative 1 times 0 is 0. 2 plus 0 is 2. So that's the remainder. And if I evaluate the function at negative 1, I get 2. So again, those match up. So hopefully you're convinced that it works. Okay. Next group of problems. Use synthetic division to show that x is a 0 of the third degree polynomial equation, and use the results to factor the polynomial completely. List all real zeros of the functions. So we have x equals 1/2 is 1, 0, which is a factor of x minus 1/2. So the way you prove this, okay, so I guess I've already done these two. I got a long way before I realized that wasn't recording. So let's so if I divide this by the factor x minus 1/2, or I use synthetic division positive 1/2, I need to get a 0 remainder, which is what happens. So you'll see I write the coefficients 2, negative 15, 27, negative 10 of the equation. Put them up here. Bring 2 down. 2 times 1/2 is 1. Negative 15 plus 1 is negative 14. 1/2 times negative 14 is negative 7. 27 plus negative 7 is 20. 1/2 times 20 is positive 10. Negative 10 plus positive 10 is 0. So that shows that one of the factors is x minus 1/2. What we've got left is 2, negative 14, and 20. So the quadratic equation that I have remaining is 2x squared minus 14x plus 20. And we want that also to be equal to 0. So we can factor out a 2. So this becomes x squared, this becomes negative 7, this becomes positive 10. And then we can factor that by observation. So you've got two numbers multiplied together to get 10, added together give me negative 7. So because this is negative 7, these both have to be negative. This is positive 10, so they have to be both the same sign. So what that means, these are the other two factors, and if I wanted to rewrite the original equation in its factored form, I would take these three things, multiply them together, and then multiply them by the remaining factor that I was initially told. So that's the factored. All the real zeros would be x equals 2. These are the zeros, x equals 2, x equals 5, x equals 1/2. So this function is going to intersect the x-axis of these values of x, 3 values of x. Okay, so let's go to the next one. So this is interesting because it has a, well, the last one had a fraction as well. They don't have to be fractions, but so the factor associated with this is x minus 2/3. This is the 0. This is the factor. So we take the coefficients from the polynomial: 48, negative 80, 41, negative 6. Write this up here. Bring this down. 48. 48 times 2/3 is 32. Negative 80 plus 32 is negative 48. 2/3 of negative 48 is negative 32. 41 plus negative 32 is 9. 2/3 of 9 is 6. Negative 6 plus 6 equals 0. So that's the key thing. Because that's 0, we know that one of the factors is x minus 1/2. What we have left over is 48x squared minus 48x plus 9. That also has to equal 0 to fully factored. So we're going to use completing the square here. So we factor out 48. So we get x squared minus x. We take the 9, put that on the other side. Make it negative. So positive 9 becomes negative 9. Then what we do is we take the coefficient in front of x, which is negative 1, divide that by 2, and then we square the result. So negative 1/2 squared is positive 1/4. So we add 1/4 into these three. To balance that, we've got to add the same amount on the right hand side, but we didn't add 1/4, we added 1/4 times 48. So if you take 48 divided by 4, you get 12. So we add 12 to the other side. Add 12 to this side, add 12 to that side. We can then collapse this as a complete square by taking x plus the quantity that's inside the parentheses here, which is negative 1/2. So on the right hand side we have 12 minus 9, which is 3. On the right hand side we have 48 times x minus 1/2 quantity squared. We want to solve for x. Those are the zeros. So divide both sides by 48. Take the square root. So you're left with x minus 1/2 is equal to plus or minus the square root of 3 over 48. And then add 1/2 to both sides. You'll get 1/2 plus or minus the square root of 3 over 48. So those are the other zeros. So we're going to look at this two ways. We're going to rewrite the original equation as in its factored form. So what we'll have is we'll have 48 times, well, did we do it? Yeah, I think so. So we've got, what we're looking at is square root of 3 over 48 x minus 1/2. No, that's not right. They're both going to be. This has to be subtracted here. Because you subtract. So to go from this, you're saying what I'm going to do is I would subtract 1/2 plus or minus the square root of 3 over 48 equals 0. So this gets it in its factor form, so it's x minus this number. That's the factor. And the factors are this plus the square root of 3 over 48 and minus the square root of 3 over 48 that, one parenthesis to match that, and then parenthesis. And then the third factor is, I guess, the easy one, x minus 2/3. So that's the factored version. The actual zeros, if I wanted to do the zeros for this thing, there would be 3 zeros. One would be x equals 2/3. One would be x equals 1/2 plus the square root of 3 over 48 and x equals 1/2 minus the square root of 3 over 48. Now, you may not believe me, so maybe I did make a mistake. We'll find out. So what I'm going to do is put these in decimal form, and then we can plot them and verify that I did it right. Because I should see that the function intersects the x-axis at those values. So let's see what I get. So the third term is 1/2 plus the square root of 3 divided by 48. So that's 0.75. Oh, interesting. Is everything right? Guess so. Let's get 0.75. And this must be 0.25. Why? Because why is that true? Okay, let's look at that. That's interesting. So we got square root of 3 over 48. So you've got the square root of 3 divided by the square root of 48. And 48 is 16 times 3, so you get the square root of 3 times the square root of 16. These cancel out. So you get 1 over the square root of 16, which is 1 over 4, which is a quarter. So that's why you get a half plus a quarter and half a minus a quarter. Cool. Okay, so let's open up my graphing program. And we're going to plot the original function, which is right here. So we're going to have 48x cubed minus 80x squared plus 41x minus 6. Okay, so that's it. We'll graph it. And notice here, so here it is. It's intersecting the x-axis at 3 places. And if I take my cursor here, you'll see it says 0.25, which is what we wanted when we got, so that's good. The second one is 0.666, so that's 3/2, and the final one is 0.75. So bingo, I did it correctly. So yeah, that was kind of challenging, but challenges. The next group of problems says verify the given factors of the function f. Find the remaining factors of f. Use your results to write the complete factorization. List all the real zeros of f and confirm your results by using the graphing utility. Okay, so that last part's kind of what we just did here. Okay, we haven't actually done, I haven't done these yet, so how many of these do I have? 2. Okay, so the way you can tell whether these are factors is to use synthetic division. So I'm going to take the coefficients in front of each term, and that every flavor is taken into account here. So I've got x to the 4th minus 4x squared cubed minus 15x squared plus 58x minus 40. And one of the factors is x minus 5, so that means a 0 of 5. Okay, so what we're looking for is a remainder of 0. That confirms that these are factors. So bring down a 1. 5 times 1 is 5. Negative 4 plus 5 is positive 1. Sorry. 5 times 1 is 5. Negative 15 plus 5 is negative 10. Well, 5 minus 15 is negative 10. 5 times negative 10 is negative 50. Add these two together, you get 8. 5 times 8 is 40. Get 0. So check. That's one of the factors. Okay, do the same thing with negative 4. Because the corresponding 0 would be negative 4. Write these down. Okay, bring the 1 down. Negative 4 times 1 is negative 4. Add these together to get negative 8. Negative 4 times negative 8 is positive 32. Add these two together, you get 17. 32 minus 15 is 17. 4 times 17. 4 times 17 is 68. So we get negative 68. 58 minus 68 is negative 10. Negative 4 times negative 10 is 40. Add those together, you get 0 remainder. Okay, now, so that verifies that these are factors. Now the question is, how do you get, so yeah, another way of doing this would be to, once you've gotten this with a 0 remainder, we could have also proved that negative 4 is a factor by taking these, so dividing, what we do is take what's left over, 1, 1, negative 10, 8, and divide by the other factor. So we'll see it works out. We'll see. Bring the 1 down. Negative 4 times 1 is negative 4. Add these two together, you get negative 3. Negative 4 times negative 3 is positive 12. Add these two together, negative 10 and 12, you get 2. Negative 4 times 2 is negative 8. And you get 0. So the advantage of doing it the second way is what I have left. So in terms of my factoring, I've got x minus 5, so that worked. I've got x plus 4, and I've got these 3 remaining terms, which is x squared minus 3x plus 2. And a lot of times this remaining quadratic one we can just do by observation, because they make it so it works out that way. So you can see I have x, I have x. What two numbers multiplied together give me 2? 2 and 1. If you add those together, do you get 3? Yes, as long as they're both negative. So this is the factored version. So that's part A. Verify the given factors of the function. So that's what we did here. First thing. Find the remaining factors. So we took the remaining quadratic and just factored it. Part C. Use your results to write the complete factorization. There we go. So x to the 4th minus 4x cubed minus 15x squared plus 58x minus 40. is equal to that. List all the real zeros. So this is C. This was D. This was B. Was just going from here to here. That's B. Okay, so D, list all the real zeros. Well, they are the values of x that cause each of these factors to go to 0. So x minus 5 equals 0. Solve for x, you get x equals 5. Here you get x equals -4. Here you get x equals 2. Here you get x equals 1. So those are the zeros. And then the final thing we do is we plot this function and confirm that this is where the function crosses the x-axis. So let's go ahead and graph this function. X to the 4th minus 4x cubed minus 15x squared plus 58x, and what's the, I forgot what the last thing is, minus 40. Minus 40. So we graph that. We got to go back to standard. And you can see we've got the function crossing 4 places. 1, 2, 3, 4. So what we see is -4, +1, +2, and +5. -4, +1, +2, +5. So that's how you would do it. You plot it, verify where it crosses. Now I'm going to zoom out in the y direction just to show you what this thing looks like. So there it is. It's x to the 4th, so it's going to be an even. It's going to be an even function. See the end behavior. You can see the 3 values of x where it 4 values of x where it crosses the x-axis. Okay, so that's number 12. Number 13, do the same thing. Got these two. So how do you handle this? Well, if I factored out a 2, you'd have x plus a half here. And if I factor out a 3, I'll have x minus 2/3. So the reason I did that is I know that the 0 would be x equals -1/2. And the 0 here would be x equals positive 2/3. So that's what I'm going to use when I use my synthetic division. So again, I'll take my coefficients: 6, 41, -9, -14. Use -1/2 here. What I'm looking for is a 0 remainder, so I'll put a little square there so I can put 0 in when I get there. Okay, so we bring the 6 down. 6 times -1/2 is -3. 41 minus 3 is 38. Half of 38 is 19, so I get -19 here. Go ahead and the negative times positive. -19 minus 19 is -28. -1/2 times -28 is positive 14. You get 0. Okay, so that confirms that's one factor. What I'm going to do is I'm going to use these coefficients that are left over. 6, 38, -28. And I'm going to use 2/3 right there. Okay, so bring that down to 6. 2/3 of 6 is 4. 38 plus 4 is 42. 2/3 of 42, well, 42 divided by 3 is 14, is that right? Yeah, 14. 14 times 2 is 28, so you take this times 42, you get 28. You get 0. So that, again, that shows that this is a factor. And what you're left with is 6x plus 42. So let's go ahead and do what we know already. We got 2 times x plus a half, 3 times x minus 2/3. Notice I've got 6 here, 6x cubed. I've already got the 6 taken care of, so I really don't need these extra 6's here. So all I'll do is I'll divide both of those by 6. So I'll get that. The reason I have this is because I didn't take into account these two numbers when I did that. And the main reason was because when to use synthetic division, I need I don't need 2x, I need just x. But when I got to this point, I realized I've got 2x times 3x, which is 6x squared, times x, which is 6x cubed, so to make it all work out. So here's the factored version. I could move the 2 and the 3 together, so I could get 6 times x plus 1/2, and x minus 2/3, and x plus 7. So that's the factored version of this 6x cubed plus 41x squared minus 9x minus 14. The zeros are going to be x equals negative 1/2, x equals positive 2/3, and x equals negative 7. What values of x make these go to 0? X plus a half equals 0, x equals negative 1/2. Okay, so those are the zeros. And then the last thing was to plot this function and show that it really worked out. So let's plot the original function that we had, which is 6x cubed plus 41x squared minus 9x minus 14. So we do that, and let's see, I need to shift this a little bit so I can get all 3 intercepts. So let's slide that over here. So here you can see x equals negative 7, which corresponds to that one. You've got one here which is negative a half, and then the third one is positive 2/3. So that verifies that this was done correctly. And then the final thing is to simplify these rational expressions. So to simplify them, basically carry out the division and rewrite it. So you'll have some, because I have just x here, I'm going to have the simplified version will have something times x squared. Now because I have 2x and 2x minus 3, in this case I want to use long division. I could factor out a 2 if I wanted to, but we haven't used long division for a while. So let's do that. So we're going to take 4x cubed minus 8x squared plus x plus 3. We're going to divide by 2x minus 3. So the question is, what do I need to multiply 2x by to get 4x cubed? So the answer is 2. 2 times 2 is 4, and x has to be multiplied by x squared. So we multiply this now by those two terms, so we'll get 4x cubed, and then negative 3 times 2x squared is negative 6x squared. We're subtracting that, so that these go to 0. So you've got negative 8 plus 6, which is negative 2x squared. Okay. So now we bring this x down from the original expression, and we ask, what do we need to multiply 2x by to get negative 2x squared? Well, the answer is negative x. Negative x times 2x is negative 2x squared. And then we take negative x times negative 3, which is going to be positive 3x. But we're really subtracting that. So negative 2x squared plus 2x squared is 0. 1x minus 3x is going to be negative 2x. What do we need to multiply 2x by to get negative 2x? And before we do that, let's bring this number down to plus 3. So we need to multiply it by negative 1. Negative 1 times 2x is negative 2x. Negative 1 times negative 3 is positive 3. We're going to subtract that. Get 0. So there's a 0 remainder, which is nice. So this simplified, we don't have a remainder, so that's nice. So we just end up with 2x squared minus x minus 1. I feel good that's the right answer, because chances of me coming out with a no remainder, if there really was a remainder, is pretty small. Now the next one, we could use long division, but let's use synthetic division here. If we get a 0 remainder, we'll be happy, but we don't need to get a 0 remainder. So we take the coefficients associated with the polynomial in the numerator. We have a factor of x plus 1, so we're going to use minus 1 here. We bring 1 down. Negative 1 times 1 is negative 1. 3 minus 1 is 2. Negative 1 times 2 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 1 times negative 3 is positive 3. It's 0, a remainder. So what this leaves us with is 1x squared plus 2x minus 3, or x squared plus 2x minus 3. So this is equal to x squared plus 2x minus 3. Okay, so we're done.